All right, we're in section 27 of the notes, and we're going to go to the whiteboard and do the examples now. All right, so give me a second to go to the whiteboard. And one question at a time. And certainly they say answer questions A through D below for that given graph. All right. So before I discuss the graph, I just want to go through preliminary what I would be doing looking at the graph. You know, looking at it, I probably would, since it's a calculus class, I'd probably write down derivatives first off. So I'd write down f prime. I don't know what the questions are yet, but that's going to be 12x cubed minus 12x squared, and then minus 24x. Well, that's pretty simple. I can write down f double prime, and that would be what? 36x squared minus 24x minus 24. I'd probably factor these guys too. All right, so 12x x squared minus x minus 2. Well, let's see if I can do that. 12x x and x, 2 and 1 minus plus. All right. So, you know, the question is, why would you have done that? I don't even know what the questions are yet. I'm so used to doing it. This is going to be the first derivative. We got a picture to help us with this. Let's see, 0, and then minus 1 and 2. All right, let's take a look. Number after 2, like 3, plug it in, positive. What does that mean? Increasing. Let's take a number between 0 and 2, like 1. That would be negative. That means it's decreasing. Take a number between minus 1 and 0, like minus half, plug it in, negative, positive, negative. That's positive. And number below minus 1, like minus 2, negative, 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 so overall negative. So what do I now know? I know there's a minimum at minus 1, f of minus 1. Look at the graph later. I know there's another minimum at 2, f of 2. Again, we'll look at the graph later, and a maximum. And these are local. And the maximum occurs at 0, f of 0. I'm going to look at my picture, see how we did. And I'm seeing the minimum at minus 1 right here, local. I'm seeing the maximum at 0, 0. And I'm seeing a minimum at 2, f of 2. Looks pretty good. All right, let's do the second derivative now. Looks more complicated to me. It is quadratic. I'm going to factor 12 out. And again, I don't know what the questions are yet. I'm just saying automatically this is what I would be doing. That's going to be 2, not 2, that's 3, right? 3x squared minus 2x minus 2. And that doesn't look factorable to me. Man, how much I can do about that. For example, you could try 3x and x, and then 2 and 1. That's just not going to work. So I got to do something else then, right? So I got to erase this over here. And let's put this down now. So x will equal, let's see, twice the a, which is 6. I get minus the b, which is 2, plus or minus. Let's see, b squared is 4, minus 4, times a, times c, which is minus 2. So I'll just do this over here. I got to keep doing this. And this is a problem for me because it requires me looking at a number that's much more difficult than integer. So let's see, you get, well, 3 times 24, 28 over 6. And I'm going to do this over here, 2 plus or minus. Well, that would be 4 times 7, which is 2 root 7 over 6. And this would be 1 plus or minus root 7 over 6. Again, mistakes happen. And that's one thing nice about having a key. When mistakes happen, I'll know I made a mistake. I got 2 points over here, second derivative, by the way. And that's going to be 1 minus root 7. Did I say 6? I meant 3. Get my eraser out. What's a good number between minus root 7 over 3 and 1 plus root 7 over 3? I'd say a good test point over here would be 0. A safe one over here would be like 10. And a safe one over here would be like minus 10. All right. And your mileage may vary. You may say, I want to do different numbers. You can. Let's look at that derivative and plug in 0. Would you get? Negative number. Concave down. We'll look at the picture later. And then what do I get at 10? What would I get? Positive. And at minus 10, I get positive. I'm looking at the second derivative, by the way. So I got points of inflection now, POIs. What are they going to be? 1 minus root 7 over 3, f of 1 minus root 7 over 3. These are nasty numbers, I know that. The other one's going to be 1 plus root 7 over 3, f of 1 plus root 7 over 3. By the way, if a mistake happens, I'll know it by looking at the key. And so, for example, over here, I kind of say points of inflection, kind of looking at it, concave up. I'm seeing that. There's going to be a point of inflection over there, concave down, and then concave up. And I certainly know those points of inflection now. All right. Now, granted, they're not nice numbers, but I kind of know that. So, I'm going to go next page, and I wonder what the questions are. So, question is the intervals where f is increasing, and they say minus 1 to 0, 2 to infinity. Let me go back and see if I did that. Increasing minus 1 to 0 and 2 to infinity. That was done. And again, it's written up for you for a reason. We want you to write it down too. All right, let's go to number 2. The intervals are decreasing, minus infinity, minus 1, and 0 to 2. Well, let me go back. Minus infinity to minus 1 is decreasing, and 0 to 2. Well, we're doing all right. Finding intervals where it's concave up. Wow, let's see if we did that. Oh, right over here. That's concave down. This is concave up. This is concave up. We did that. So I'm going to say minus infinity to 1 minus root 7 over 3. Right? And then the other one, let's see if I did put that down. 1 plus root 7 over 3. Yeah, to infinity. That looks good. Concave down in between those guys. We have that. We did good. All right. As long as you did more than they asked for, you're right. I found the mins and maxes on it. They were just looking at the increasing, decreasing, not the min maxes, but it can't hurt. All right, let's take a look at number 2. And they want me to do something first. They want me to verify. And let's write this down. F of x. That's going to be x squared plus 1 over x plus 1 to the half power. And f prime, don't be alarmed. I have an answer to aim for at least. All right, I got to do something now. I got to multiply it by the derivative of the inside. And that's going to be x plus 1 squared, x plus 1 times 2x minus x squared plus 1 times root of the bottom, which is 1. Well, I got some work to do, don't I? Let's put this down. 1/2. I'm going to say it looks like x squared plus 1, x plus 1. And I'm going to put that to a half power now. Let's see what happens. Times x plus 1 squared. That's not so bad. And what do you get on top there? Again, we check. We'll check with the k. That's going to be what? 2x squared minus x squared, which is x squared. 2x. I'll put that down. And then you get minus 1. All right. So see if we got it. I'm looking at it. And I'm seeing this. I'm seeing this. I'm seeing that half right over there. And now I'm seeing other things. And I don't know if I'm seeing them. So let's take a look at it. And what am I seeing? I'll write it down. I'm seeing that there's a cancellation here, aren't I? And I want to point out it would be x squared plus 1 to the 1/2 on the bottom. This is on the bottom. So look at the bottom now. And then what else on the bottom now? It would be x plus 1 Well, a half from that would be 3/2, right? So I'm starting to realize that this guy over here is x squared plus 1 times x plus 1. Well, that's 3/2, right? So that's 1.5. So it's x plus 1. Let's see if we got that. Well, I'm seeing the x plus 1. I'm seeing this. I'm seeing this. This looks good. We just verified it. All right. That was good news. All right. They give me a graph. Let me look at the graph for you. And this is the graph over here. So let's answer the questions. What's the domain of the problem? How do I do that? Oh, it's back in 119. How do I do that? Well, I'm looking at the function and the radicand. I got to charge my battery up. Give me a second. This happens to me often. I forget to charge things, and then all of a sudden it says, your battery's running low. Plug it in. I'll plug it in. So we get x squared plus 1 over x plus 1 must be greater than or equal to 0. There's only one number I have to worry about, and that's at -1. Now, I notice that at -1, it's the only place where the bottom becomes 0. The top is never 0. But I can't use -1 because it would be undefined there. But take a test point after -1, like 0, plug it in, and it would be positive. So the domain of it is from -1 off to infinity. Let's see how we did. Got it. All right. Next question. Whoops, I'm sorry about that. The next question is, what's the y-intercept? Let's see if we can do that. To get a y-intercept, what you do is set x to be 0. So I'm going to get y-intercept now. I'll set x to be 0, so that's f of 0, and you're going to get this, 1 over 1, which is 1. So what's the y-intercept? Well, x is 0, y is 1. Let's see if I got it right. Gee, the equation of the vertical asymptote, well, that's fairly simple. The vertical asymptote is going to be at x equals -1. All right, that's the vertical asymptote. And what I want to do is I want to look at a limit. The limit as x approaches -1. There's only one place you could approach it by is by the right. So that's plus of the function, x squared plus 1 over x plus 1. And what would you get over there? I hope you can reason through this at this point. The top would become 2, and the bottom would get close to 0 from the right side of it. Yep, it's going to blow up to infinity. All right. Vertical asymptote x equals -1. Let's see how we did. And I did that. Works over there. Evaluate the limit as x goes to infinity. Let me do that. Whoops, sorry about that. I'm going the wrong direction. And let's see what happens. What happens? Limit. They asked me to do it. Limit as x goes to infinity of the square root x squared plus 1 over x plus 1. Well, the top grows much faster than the bottom, so it's infinity. All right. So we did that. That's done. Let's go to the next question. Next question is the global minimum point on F. Let's go back over here. And I'm looking at a picture now. And I know looking at it that this is the global minimum point. Okay. So what do we do over here? I got to look at that function, its derivative. And let me go back to that for you. And this is the derivative over here. And it looks complicated. There's no doubt about it. And so I'll write that down for you. And what am I looking for? I'm looking for when that derivative takes on, a 0. And the other place I'm looking at where it's undefined. It's undefined at -1, but that's not in the domain, so I can't deal with that. So really, the only thing I'm looking for is I'm looking when does x squared plus 2x minus 1 equal 0? Well, I can't factor that, but I can do this. I can use quadratic formula. 2, that's going to be a tough one. Let's see. Opposite of b is -2 plus or minus. Yeah, you need the quadratic formula, by the way. There's not much else you can do about it. You can complete the square root if you want. You know what to do? I am going to complete the square root. That's ridiculous to do this over here. I can complete the square, much easier. And it's a good chance to review it too. So x squared plus 2x equals 1. Half of 2 is 1 squared plus 1. This is going to be a perfect square. X plus 1 squared equals 2. Square root, where you get x plus 1 equals plus or minus the root of 2. And then you get x equals -1 plus or minus root 2. Well, there's 2 of them. What do you get over here? -1 minus root 2 And the other one's going to be x equals -1 plus root 2. Unfortunately, this one can't be in the, not the domain of the problem. So there's only one critical number. And I want to go through it with you. So I'm starting at -1, and I'm going to be root 2 -1. And yeah, it's tough. I realize that. A good test point over here would be 0. A good test point over here would be, I don't know, 10. Let's go back and check, test it out. If I do 0, I definitely get a negative number. If you're wondering where I'm testing this thing and why I can do it so quickly, I'm testing it here. All right. What number did we test? We tested out 0. And 0 would give me a negative number top. The bottom's always positive looking at it. All right. What's the other number I said? 10, right? Remember that? Let me go back over here. Well, 10 on top will give you a positive number, and on bottom it's all positive. So what I know, increasing. Decreasing, increasing. So I found the minimum. Let's go back over here. And it occurred at the point root 2 -1 f of root 2 -1. Let's look at the key, see how we did. And where is that? Yeah, next page. Yeah, right over here. By the way, I did do some work over here. I did the evaluation. No, you don't have to do that. All right. The range is pretty easy to do. Looking at the picture, I know where it bottomed out. It bottomed out at f of root 2 -1, and then it went off to infinity. All right, that's right here. And again, I did the arithmetic on it as well. All right, so given that, now, by the way, someone says, are they giving these things? Should I trust them? I think so. I really think you should trust them. However, I always say trust is really a dangerous thing. If you trust that what I've done is correct, that's fine. But I'll be honest with you, I wouldn't be trusting anyone at this point. I would verify these guys. I'd verify each one. All right. They gave me a partial graph. Let's look at it. I'm seeing that. That's not bad. I see that. And let's go through what you would have done in Math 119. Right. In Math 119, what you would have done was you would have done a long division. And the reason that the degree at the top is one more than the bottom. And they told you to do it. Let's see what you get. You get x squared plus 1 is being divided into x cubed minus x squared. I'm sorry, it's -1. Make sure I copy that down right. Yeah, let's go for it. What would you get? Oh, just x, I guess, right? Or they give you x cubed plus x. I subtract, you get minus x squared minus x minus 1. And not very interesting, by the way, but you could write that down. And what are you going to put down? This would be x minus, on the bottom is x squared plus 1. And the top would be x squared plus x plus 1. All right. Oh, you know what? I could go further than that. I'm sorry about that. I didn't realize that. I mean, I could write that down, but that's not the full picture at this point. And let me just erase this. There's a point to it. So, oops, sorry about that. I didn't mean to do that. -1. That would give me minus x squared minus 1. And what do you get there? Well, you just get minus x. All right, let me write that down. So you get x minus 1 minus x over x squared plus 1. So what do I now know? I know the domain of the problem is all real numbers. I know there's a slant asymptote SA, and that's y equals x minus 1. All right, let's look at that. And I'm seeing that. I'm seeing the slant asymptote clearly. This is y equals x. And I'm seeing the picture as I expect. It's asymptotic with that. Now let's talk about the points. And the points I'm looking at are the x and y intercepts. So let's set x to be 0. Again, I'm looking at my graph. If x is 0, what would y be? It would be -1. That's easy. Right, so point do I get? 0 minus 1. Let's go to the picture. This point over here is 0. minus 1. Let's see if we can get this point. Might be tough, but let's take a look at it. And what do I do there? I set y to be 0. And if you did that, what would you get? X squared plus 1, x cubed minus x squared minus 1. It's a cubic though. And I'm going to say it's probably pretty easy. I'm going to say it looks like it looks like when y is 0, the x would be 1. Let me just check that out. You get 1. No, it's not 1. Let's go back to the picture. Sorry about that. Oops, I got this picture over here. What am I doing here? Where's my picture? Oh, right over here. No, it's not 1. It looks like it may be difficult to come up with, but all I can say over here is I don't even think I can ask for it. All I know about over here is 0. I don't want to bother. It's just too much work. If they ask for it, I'll bother. But right now it wasn't 1, so I really can't do that. So let's take what they want. Oh, the domain, we've already done that. All real numbers. The y-intercept, we've done that. All right, the equation sign asymptote, we've done that. X minus 1. I keep doing that over and over again. Let me point out where that is. It's right over here. All right, really, I'm going back and forth to the paper. I sometimes forget. See, you know, much memory here. Find the inflection points. I guess I got to go back to that second derivative, right? And I'm going to look at it. And let's look at it. I'll put a number line. And we got an inflection point candidate at 0 and at plus or minus root 3. Well, I've been doing sign analysis since 119, and I think I'm ready to do it. Now, if you take a number after root 3, like 10, it's going to be negative, which means it's concave down. If I take a number below minus root 3, like minus 10, I would get negative times a negative, which is a positive. Look at the picture later. Whoops, sorry about that. And then between minus root 3 and 0, let's go between 0 and root 3, 1, you get positive. And if you took a number between minus root 3 and 0, like minus 1, plugged it in, you would get negative. So I got 2 points of inflection. I'm sorry, 3 points of inflection. Minus root 3, f of minus root 3, 0, f of 0, and the other one's going to be root 3, f of root 3. Let's see if they told me I had the same agreement. And let's take a look at that. And I have them over here. All right. And they also put down the computation. I didn't do the computation, but you're more than welcome to do that. It's not that bad if you want to do it. Let me see if there's any other questions with respect to that. No, there isn't. Okay, this one over here, it's just a, it's like a reprieve from all the work. It's a difficult graph though. I would not suggest, taking derivatives over here. It's just too much work, but I do see some symmetry. And what do I notice about this guy over here? Maximum, these are local, by the way. Maximum, 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 maximum. How many maximums you get? An infinite number. They're all going to be local. Minimum, minimum, minimum. By the way, this one over here is a global minimum. This is global minimum, minimum, minimum. What's this one over here? It's also minimum, but it's not global. Are there points of inflection? It appears to be that way. This is a partial picture, by the way. Concave down. Then it looks like over here it goes concave up, concave down, concave up, concave down. You get the idea. All right. Pretty simple. All right. Here's the problem, though. Getting those things might be really tough to do for a problem like this. Is it doable? Probably. All right. Let's take a look at this one over here. And I'm seeing that they give me a function, and they're kind enough to give me a graph, and they ask some questions about it, and I'm going to go through it with you. All right. And I want to see if I can get that derivative. I'm going to write this over here for you. So f of x equals x to the 1/3 times e to the minus x squared. Let's put this first derivative down. I'm going to see if I can get it. Might be tough. I'm going to say the derivative of the first function, which is 1/3 x to the minus 2/3 times e to the minus x squared plus the first function, which is x to the 1/3, times the derivative of the second function, which is e to the minus x squared times minus 2x. Right, I got to clean this guy up because it really looks bad. It really, really looks bad to me. So I'm gonna look at it, and I think I want to get a common denominator. 3 x to the minus 2/3 e to the minus x squared. That would be minus 6 now. Let's see, x times x to the 1/3 is x to the 4/3, right? Times e to the minus x squared. Well, generally speaking, we like to factor if we can. I'm going to look at that. And I got to be careful here. And I'm going to factor out, it's going to sound crazy to you. I'm going to factor out e to the minus x squared. I'm also going to factor out x to the minus 2/3. By the way, if it doesn't work out nicely, I would stop and just leave what I got over there, or maybe try something different. But this would be 1 minus 6. Let's see, what would that give me? 6/3, right? And what's 6/3? It's 2. Yeah, you would need to know arithmetic. Over 3. And I don't like the negative power, so I'm going to write a little differently. So 1 minus 6x squared e to the x squared, and then it's going to be x to the 2/3. Let's see if I got the right derivative. I got the top. Oh, I forgot the 3. Sorry about that. 3x, yeah, I got that. And x, yeah, I got it. I did it. This is good news. All right, now what's the question? I don't know. Find and simplify. I did it. Find and simplify. Ooh, second derivative. What I'm going to do? I'm going to take this guy here. I'm going to copy it. I just did this, remember? And we're trying to encourage you to do this as well. You must have the teacher do it. Why do I need to do it? No, you're the one who's supposed to be learning this material. Let me paste it in. And I'm going to start differentiating that. And how would I do that? Well, it's quotient rule, right? It's going to be a lot of work. Square the bottom. It's work, though. I know that. Bring the bottom to the top. Times the derivative of the top. Minus the top. Times the derivative of the bottom. Well, that's going to be a lot of work for me, but I got to do it for you. So what's it going to be? 3e to the x squared times 2x times the second function, which is the cube root of x squared, plus 3e to the x squared times the derivative. I'll write this down for you. It's x to the 2/3. Its derivative, 2/3, x to the minus 1/3. What's that going to be? 2 over 3 cube root of x. I realize what some students are going to be saying now. I can't go on. It's too much work for me. I'm going to get my eraser out. It happens, so I get tired too. Wow, we got a lot of work. And I guess I got to do something here, don't I? I guess what I'm going to do, I'm going to square that bottom first because it looks like I can do it. Oops, get this out again. I'm gonna write down the bottom. It's a lot of work though, isn't it? 3e to the x squared cube root x squared. And this is down twice, right? 3e to the x squared cube root of x squared. Well, I gotta do the top. That looks like a lot of work. I'm gonna do this guy over here. Minus 36 x e to the x squared cube root x squared. That's done. Now I'm going to do this guy. Looks like a lot of work, right? Minus 3. I'm sorry. I should really do some simplification. I'm moving along. That'd be ridiculous to write that down without doing that simplification. Just too simple not to do it. So it's going to be, let's see, minus 6x e to the x squared cube root x squared. It's going to be worked out. I realize that. And then what we get. Let's see, these threes cancel off. And I'll write this down. So you get minus e to the x squared. There's a 2 over the cube root of x. A little nasty number though, isn't it? All right, I got to do this next thing, which can be plus now. I'm doing the 6 now. Let's see, 6 times 6 is 36. And then you get x cubed. I'm gonna be slow here, right? 6 times 6 is 36, x cubed, e to the x squared, and then the cube root of x squared. Boy, I got to do this now, which is going to be, whoa, it's going to be tough. Plus 12 x squared over the cube root of x. I realize what something said. I can't go on anymore. All right. I am going to start to divide the hell out of the problem. Every term has e to the x squared in it. So what I want to do is I want to divide every term in the problem by e to the x squared. Every term is divided by e to the x squared. Ooh, that last term. Oh, I'm sorry, I forgot to write it down. I'll put it in now. Sorry about that. Every term has that in it. Disappears. All right. All right, I got to do a little more work now. Let's write this down now. It's work though, I know that. So I get minus 36x cube root x squared minus 6x cube root of x squared minus 2 over the cube root of x plus 36 x cubed cube root of x squared plus 12 x squared over the cube root of x. Wow. 3 cube root of x squared, 3 e to the x squared cube root of x squared. All right, let's take a look, see if we have something to do over here. And I'm going to multiply top and bottom by the cube root of x. And let's see what we get. Who knows what's going to happen? So minus 36 x cube root of x cubed, which would be x, minus 6x cube root of x cubed, which would be x. Boy, things look like they're working out pretty well. Minus 2 plus 36 x cubed, cube root of x cubed, I mean, so it's just x, plus 12x squared. All right, let's take a look. And what do you get in bottom? You get 3. Well, then it's going to be the cube root of x cubed, which is x, 3 e to the x squared, cube root of x squared. All right, things are starting to shape up. By the way, I'm not saying I didn't make an error. I'm just saying things are shaping up for me. I get 9x e to the x squared, cube root of x squared. Well, let's see. Let's do our squares first. Get minus 36, minus 42, and plus 12. That's minus 30, right? Make sure I did that right. Yeah, minus 30, minus 2, and then 36, x4. Well, you know me, I'm going to keep going. I don't even know what the answer is at this point. I know things are getting better for me. I know it's painful though. Let's see if we got it. All that work. All that work. I'm going to take this and, you know, God forbid we make a mistake. I almost mean that too. I'd hate to think that what happens to a lot of students, they make so many errors and they get so confused that they can't go on anymore. I'm sorry, Jim. I don't want to do that. It's so much paper went on, so much work. I'm even lost where we are. I'm sorry about that. Made this thing down here so small, I almost can't grab it anymore. All right, let me just. Let's see if we got it right. Absolute miracle. This and this, 100% agreement. And that's a good story. So as soon as I can't do it, I just, or worse than that, a lot of people actually refuse to do it. And I'm not going to do that. That's just too much work. You want to find something that you're engaged in, you're able to do the work. So what I want to do is I want to talk about why they asked me to do all this work over here. And part of it is, I know it's difficult. And I'm not saying you can't, you know, whine about it. You can whine about it, but they want me to find maximal point on F. This is the picture. They gave it to me. This is called a max. And it's a global max, by the way. This is a min. And it's a global min, by the way. This is a point of inflection. This is a point of inflection. And this is a point of inflection. Let's go for it. All right. And what am I going to go for first? I'm going to go for that derivative. Now, did I copy that derivative somewhere? I did. It's right over here. Sorry about that. And you're going to see me do something that you may not enjoy, but and let's write this down. So looking at it, I know there's a couple of different critical points in this over here. I'll put them down for you. One is at 0 because the bottom becomes 0. And the other one's going to be at plus or minus, let's see, minus 1 over the root of 6 and 1 over the root of 6. All right. Now, if you took a number after 1 over root 6, like 1, plugged it in, the bottom always positive. The top I have to worry about, though. It's negative over here. Now, I know the numbers between 0 and 1 over root 6 is real complicated, but I want to go to the left of minus 1 over root 6. Well, I'm going to say minus 1. And if you plug that in, it's also going to be negative. All right, let's go between 0 and 1 over root 6. And I want to play it safe, by the way. I'm going to pick a number over here like 0.001. The bottom's always positive. And what do I get on top? Well, if I put that number in and squared it times 6, what would I get? A positive number. I'm going to do this over here. What number would I play over here? Minus 0.001. If you play on the bottom, bottom's always positive. But if you play it on the top, it's going to be positive again. So what do I know? Minimum, maximum. So what's the maximum occur at? 1 over root 6, f of 1 over root 6. Where's the minimum occur at? Minus 1 over root 6, f of minus 1 over root 6. All right. What's this thing over here? It's actually going to be a vertical tangent line, neither min or max. All right, got that covered. Let's do the POIs. Much more difficult. Oh, by the way, I should check this. These answers are listed over here. By the way, they're also computed. That's the maximum point. I did compute that. And the next one's the minimal point. I did compute that as well. Let's do the POIs. Not going to be pleasant. I think at some point you might say, I want to use a machine to do this. I'm not opposed to it. You should suffer a little bit before you use a machine though. And I'm going to say there are some critical numbers here. The easiest one at the bottom, with bottom becomes 0 at 0. That's nice. It's in the domain of the problem too. I got troubles though. I want to point out my troubles are as follows. I need to solve 18x4 minus 15x squared minus 1 equal to 0. I'm going to make a substitution. I'm going to say u equals x squared. Yep, this is going to be painful. 18u squared minus 15u minus 1 equals 0. U will equal, I'm using the quadratic formula, 36, 15 plus or minus. It's worked for me too, by the way. Let's see, 15 squared is 225 minus 4 times a times j. What's going to be plus, and 4 times 18 is 40 and 32, 72. Nasty, nasty numbers. What do you get over here? U equals 15 plus or minus the square root, 36. Let's see, 225, 297. All right, what's x? I'm sorry, what's u? It's x squared. What's x squared equal to? 15 plus or minus the square root of 297 over 36. I got troubles. I'll tell you what the troubles is. I can't have a negative number. So my x squared now, I'm in a real number, is going to be 15 plus root 297 over 36. Can't be the minus 1. The reason for that is this number is bigger than 15. What's x going to be equal to? Plus or minus, use square root rule, the square root 15 plus 297 over 6. I found my points of inflection. Not that I want to belabor the point, but you know, I want to point out this number line analysis. You'd put those numbers down. There's 2 of them. You know, one is the negative number, the other one's positive number. Go through the sign analysis. Kind of, you know, I'm going to say I got a nice picture over here. I really don't need to do that. Point of inflection over here is 0, f is 0. What's this point of inflection over here? I'll write it down for you. It's going to be root 15 plus the root of 297 over 6, f of that number. I'll write that down for you. No, I wouldn't expect anybody to compute that. And what's the other one point of inflection going to be? And again, one point of inflection is 0, f is 0. The other point of inflection is going to be minus. It's nice to have a graph, by the way, and f of minus. My only really concern right now is I wonder, did I really compute those numbers correctly? And you know me, I make mistakes a lot. Let's take a look, see if we got it. And I'll, I think I might have made a mistake somewhere. Let's take a look. I'll put these over here. Oh, yeah. I'll point out what the mistake was. I'm going to paste it in. Sorry about that. Paste. Oh, I pasted it twice. I can undo it now. Okay. I want to tell you what happened over here. I'm going to say they did a little bit of work, and I want to go through that work with you. So x equals, oh boy, there's going to be a lot of work now. Let me just write down the positive one. And it's 15 plus 297 over 36. I'm going to look at the 297. And I'm going to say 297 is divisible, but let me see, 9, yeah, by 3. Let me go through that with you. 3 goes into 297. 9 would be 27. And then you'd get 2799. I'll write this over here. 3 goes into 99 33 times. So this is what they did. I'm not saying what I did was wrong. I'm just saying what they did. And then they reduce that. And what would they get? They divide by 3. That would be 5 plus root 33. 3 goes into 36 12 times. That's how they're getting these numbers over here. Really same numbers. My numbers are the same. So we did get the points of inflection. All right, let's go back over this. I want to point out, I find this very difficult too. I mean, I don't enjoy doing it either, but I don't mind doing it. It isn't something that's like, like I dread doing it. But I'm going to say, you start to realize that, doing things by hand sometimes, it's drudgery, right? It's drudgery. But here's the deal. You need to study what we just did. You need to do the examples again, what we just did. And then what are you going to do? Then you're going to go to homework. Then you're going to see if you can actually do the material. All right. Hopefully it's been helpful. Again, if you need additional support for whatever reason, please come by during office hours. I'll be more than happy to help you.